There you go.
Hi, my name is Toby Scott. I work for Huntington Ingalls Newport News Shipbuilding, and I will be doing the number 1 problem of the co-op dealing with the I-beam. As you can see right here, I've already drawn a picture of the I-beam. First question I had to solve was finding the centroid and finding the centroidal moment of inertia. I used my calculator to do that, of course, which is the ME Pro program that is installed on my calculator. It gave me a centroid of 8.625 inches and gave me a centroidal moment of inertia of 1,196.44 inches to the fourth. After that, I found my Q. And the Q that I found was my top Q and my bottom Q. And as you can see right here, to find my top Q, I took the total distance of 15 minus 0.75. Then I minus the 8.625, which was given to me in the calculator, and that gave me 5.625. I times that by the area of the flange at the top, which was 10 times 1.5, and that gave me my top Q, which was 84.375 inches to the third. My bottom Q was simply found by using the 8.625 inches and subtracting my 0.75 from that, and that gave me the 7.875, and then I times that by the area of the smaller flange, which gave me 70.875. So I have both my Q's for the top and bottom, but I still must find my Q max, which I found by using the previous bottom Q, 70.875, and I simply added the 25.3828 that I got from the remaining piece of the web here. And I added that to what I had, and that gave me a Q max of 96.2578. After I found my Q max, the next thing I had to do was find the V allow, which is the shear. And as you can see, we were already given that's an allow for the wood of 250 pounds per square inch. So the formula reads T allowed equals VQ divided by IT. I put my 250 pounds per square inch on the left side, place my Q max that I found, the 96, and I use the inertia times the T, which is the thickness of the web. I did all the math work, which is just simple algebra, and I came out with a V of 3,107.38 pounds. After I found that, the next thing I had to do was find my Q for the top and the bottom flanges. Well, luckily I've done that already. I showed you before that my top was 84.375 and the bottom was 70.875. So I actually took care of that before the actual question came about. So moving right along, my smaller Q, I found that formula is VQ, whichever Q that you use for the top or the bottom, divided by I. Took my V shear here, multiplied it times my 84.375 Q top and divided it by my I, gave me my small Q top. Same thing for the Q bottom. Got that here, right here. Gave me my Q bottom, which was 184.076. After that, basically the last thing to do was to find the S, which is the spacing of the nails.
45 seconds.
Okay, I did it for the top here, and I did it for the bottom there. The formula is V divided by Q. 500 divided by 219 gave me 2.28 for the top. Did it for the bottom as well. The 500 divided by 184.076 gave me 2.72 inches for the spacing for the top and bottom. That's my answer for my number 1. Thank you for listening. You guys have a good night. God bless you. Thank you.